apply and the effect it will have on the conventional current direction of the diode. Okay, I will explain that later. Determine the applied voltage or our transition voltage that will result in a change of the state for the diode from on to off, off to on, and on to off. Ang kana siya transition voltage class, di ba magsige magdagan ato ang atong input. At a certain voltage, ana siya mo transition. And based on siya, inigtungtong na niya nga certain voltage, ginitawag na transition voltage, diha mo transition to off. Okay? Now, yung off, mo transition na po siya. Ato niya na nga number on. Okay? On, off, on, off. Now, that transition value is ginatawag na itong transition voltage. And it's very helpful in doing analysis. Okay. How to find or determine our transition voltage. Okay. So, if we have here, okay, same thing kanina, may bias. We have a circuit here. Okay? Now, wala na siya ihatag na input signal value. But this is sinusoidal one. Hatag niya sinusoidal. So, in here, we have a DC. We have a diode, of course. Diode din ka diode. May diode na siya. Resistor. Now, in getting the transition voltage class, si diode, as is niya nga ideal. Okay? Since ideal, as is pa dyan na niya nga, i-reverse bias ko niya si diode. Now, since diode is on reverse bias condition, therefore, there is no current. No current, no voltage output. Okay, muna siya yung given direct ka na. ID is equals to 0 milliampere. So, just 0. Okay? Now, in doing this one class, kung saan may pagkuha? No, so, si output, 0 na. Output is across our R. Okay? Ang R na voltage drop na VR. Now, since VR is across our VO and VO is equals to 0, therefore, VR is also equal to 0. So, 0 na siya. So, mulog ka dire. Sorry, Lord. Okay. So, VI, okay? Positive man ta mo gawas. Gawas po ta diri nga element minus 1 sad. Okay? But that's a V. Okay? Napapay sumpay na 0 equal to 0. Use this as 0. Okay? So, VI transpose V to the other side of the equation is just equal to our V. So, atong transition voltage is just equal to our V. Okay? That is for ideal. Ideal pa ta, ideal pa ta. Okay. Muna siya ginatawag rin. Now, after ni mo mabuhat si transition voltage class, paitaon ni mo in its off state, on state, on state, and then off state. Now, in off state, on state, okay, direct class. Now, in on state, okay? In on state class, so, dili na ta mo matter nga, dili na to i-as is nga reverse bias automatic si diode. Balik na ta sa regular nga forward reverse bias condition, on state, off state. Now, as is, okay? Ideal lang sa gihapon na siya. So, make a loop in an on state. For example, this is the signal. This is the positive half cycle, negative half cycle. Now, in on state or our positive half cycle class, so make a loop.
On state ang diode.
VO is across the voltage drop of our VR. So VO is equal to VR, which is VR equal to VO. So VO. Sabot ko? Diba? Kung parallel, diba nakaparallel sila sa story.
Yes, yes.
In measuring our output voltage, na since naaman siya yung element diha, so ano na ito makuha ang iyang output voltage? Okay, this is our load resistance. Kung unsay voltage drop ani atong resistor mo, atong output voltage. So silbi VO is equals to VR. Okay? Equal to, this is supposed to be VR man, di ba? But since they're equal, okay? So, minus VO. Kung di ko ganahan maglibog, anak na lang yung loop. Gawas. Okay? Depende na dyan na sa yung looping. So, find output voltage, transpose V out to the other side of the equation. That's just VI minus V. That's for on. How about off? At negative of cycle. Okay? So, negative, positive. Okay. Mulog pa ba ta? Dili kay reverse bias na daan ato ang diode. Negative, okay? Supposed to be na may diode. And this is positive. Reverse bias condition atong diode, therefore there is no current, therefore there is no output voltage. V output is equal to 0 volts. This is for off. Now it is often helpful to draw the output waveform directly below the applied voltage using the same scales for the horizontal axis and the vertical axis. So if we're going to draw, pasensya, hindi ko may mo. For example, this is our input. Okay, zero man siya na zero. Okay, this is our sinusoidal. Okay, one. Continue lang, perfect. Okay, so at positive half cycle class, okay, now atong drawing on kung pananglitan lang at a certain voltage, muna siya si transition voltage is a DC voltage. Diba? In a pure DC, diba? Kung pure DC, straight line naman ang ato ang signal. Okay? So, for example, we have here our DC or transition voltage. Atong VI. Okay? Transition voltage. Atong i-project class ang ilahang project ang ilahang tawag na nila intersection. Okay, now after buhatan og intersection class i-project na nimo kada opos. So, gamit of above and below. So, above our VI or transition voltage, our diode is in forward bias condition. Below our transition voltage, our diode is on reverse bias condition. Kaya, so, diri nga point, hanto diri nga point, unsa may siya? Under? Above? O below above? Transition voltage ang tanawa? Below. Since it is below, reverse bias condition. In reverse bias condition, output is?
Zero.
Zero. Okay. Pag-abot diri nga point, hangtod diri nga point, Pag abot diri ang tuliha. Forward. Hangtod sa hangtod.
Mo lang kan miss no.
This is our output voltage.
Halfway
Now,
lift.
during our original signal class, this is our VP. Okay? This is our VP.
Peak.
Voltage peak.
Peak volt.
Yes, peak voltage. Okay? Now, pag abot diri nga side, okay? Atong i-click off ang some portion sa iyang positive half cycle or positive half. Atong i-click off tanang negative. Okay? So dili siya sa ingon nga halfway rectifier lang siya. Okay? Tuod halfway, but we are clipping a portion from our positive half. Upper half. I-click tanan. Lower half. So nakikita mo nga clipping. Taking away a portion of our signal. Okay? Now, unsa naman ni siya mag-peak diri? Unsa na may amplitude ana niya? Amplitude meaning iyang a certain distance mo. Kung may term in communications. Amplitude. Pila naman eh?
Dili, naman ay kuan may value.
So this is supposed to be V peak minus our transition value. Di ba mo man ni atong peak sa una? I-cut off man nato ang ubos sa atong transition value. For example, nato yung transition value class nga 4. This is 0, 1, 2, 3, 4. For example, this is 10. 10 ang atong peak. So, ang bago nga amplitude is 6 volts.
Miss, dira ba tong kuan miss katong na ipay? Katong na ipay sa formula miss ba? Nawat ko katong nasa video miss. Katong kuan transformer na kuan miss.
I love you.
Halfway, rectifier ata na. Okay. So kani siya gini. No, that's the rectifier katong mga V peak over pi.
Kana miss.
Diba? Formula jud to niya. Okay, this time here magbase ka sa imong i-click off. Okay, mga nutong mga inday. V peak. Okay? Ikuhaan mo siya og portion. Unsa man nga portion kayo nakita? Imuha transition value. So ang bago nga amplitude ani atong output on the positive half is V peak minus our transition. Diba? Kasabot ra. Everybody.
Ang kanang ang transition value miss kanila yan siya given miss.
No. You need to find it. Yes. Not unless you have. Naman na sa circuit.
Ay kanang VI kaniton mi ay dili VI kuan na voltage.
That's the transition. Okay, muna siyang imig na. So, ang bago na output peak is V peak minus our transition. Okay, example here. Determine the output waveform for the sinusoidal input of this image. Okay, the output is again directly across our resistor. Okay. So for the positive region, the DC supply are both, the VI and the DC supply is both applied pressure, but this time is inhimo ni DC, ang murag iyang buhaton pamagian, pangitanang paagi nga iyang i-turn off si diode. Mahitabo ra na siya class kung atong VI is less than our V. If mahitabo nga si VI less than ni V, dili nakadaog si diode.
Butos diode miss.
Yeah, dili siya mubuto. Dili lang siya enough to power on. Not enough to conduct. Why? Because we are dealing AC signal. Pero kung you are just designing DC, so mawala na si AC, wala bili si AC. Magdepende na siya sa atong DC supply, battery. But this time, atong network is in AC man. So we're dealing AC right now. So for example here, okay? Now,
reverse polarity.
okay. Now first, okay, ato na na-check na asa man dapit si V output na kabuta. Okay, V output here. Na si DC na input nga binding. Okay, natay binding nga input. Mag-agad po ta sa wave class ha, sa waveform. So, we need to find next our transition voltage. Okay. So, in finding our transition voltage class, kung sa gatong buhaton, as is nato nga, diode is, ideal pa ta. Diode is, a diode is reverse bias condition, therefore there is no current, therefore there is no output voltage. Transition value pa ta class, transition voltage. Kung na siya iyahang condition, as is niya nga naka-reverse ang iyahang diode. No, correct. So kung mag-loop ta, okay, positive VI, lusot ta sa positive 5. So VI plus 5, 0. 0 man eh. Linear man na. Switch naman na. Okay? So, 0 equal to 0. Because matod pa ni KVL, the algebraic sum of all the voltages in our circuit is equal to 0. So, dapat equate to 0. Okay? So, mani siya, VI plus 5 minus 0, wala, equal 0. Transpose 5 to the other side of the equation. Atong transition voltage is negative 5. Okay? So, at negative 5, mo transition siya from on to off, off to on. Okay? Now, to find, nga natay VI. Okay, sunod na to. VI is negative 5 volts. Now, next step, we need to find it in its on and off state. So, okay. So, kung on class, positive, forward bias ato ang diode. So, we can do loop. So, positive, positive, okay, minus V out, okay, minus ka na. Minus V out is equals to 0. Okay? Now, V output, dili nang tatanaw. Ano pa na? Minus V output equal to 0. Transpose V output to the other side of the equation, muna siya may tampo. So, in off state, we have VO. VO is equals to VI plus 5 volts. That's for our on. Okay. Now, next, for our reverse bias condition. Makaloop ba ta? Magloop ba ta? Hindi na. Because our diode is on reverse bias condition. In reverse bias, there is no current, therefore there is no voltage output voltage. So V output is 0 volts. That is for off. Okay? Now, we're going to graph it. Okay? Sa panahon ka man mag-graph tani. Okay. So, if we're going to graph it class, okay, ito lang po graph. Okay. So, at positive half cycle, okay, di ba naaman tayo input. Okay? Naatay input niya, pila? B in, signal. 20. Okay? 20. Kanin siya class is, diba, ibig na. This is the transition voltage. Naka-VI lang na siya class. Okay? Pero abot dire, ang VI niya yung gimin is ang input signal. Okay? Ano na lang? Para yung maglibog, transition voltage. Okay? Una lang na, transition voltage. Okay, sa una, di ba, ang T3 is thermal voltage man, di ba? So, or threshold voltage, VTH. So, in here, kasi na lang. Para di mo maglibog. Or kung puhon-puhon, mag-study mo, di na mo maglibog, you can use again the I. Okay, so,
Miss, kuhaan miss baka ng ang VI miss dili na siya na kuhaan ka ng ang sa tawagan na ang current sa kuhaan sa circuit.
VI? V is voltage.
Naman to yung kuhaan ay
V is voltage.
Nasagol-sagol na lang ako ang mga formula, miss.
V is voltage. So, during forward bias condition, ang may formula nga VI plus 5 volts. Okay? This is supposed to be okay.
So-
Now, positive of cycle, negative of cycle. Okay. So we have supposed to be 20. Okay? But we have a DC transition voltage of pila?
Negative 5.
Ay, butang na to dire. 5. Butang na to dire, negative 5. So this is negative 5. Okay, kana negative 5 na siya, class. So atong i-project. Project.
Tingkit. May pagbali na ako. Bali na.